Hey guys, is the video over? Did you watch the video? Is it complete? Is the video over? So please change background pen color. Okay, okay, I'll change. What color do you want? Attendance link not response. See, attendance we had to give attendance. Arun, Arun will be like posting attendance. Or we'll be giving you the link. Divya Ravichandran attendance link no response. See, the attendance link there is a specific time interval. Okay, change the background to white. Dinakar says. Okay, see, which, okay, so we'll do that. Okay, okay. Please change background to white. Okay, okay, we'll do that. Attendance link. Everybody is asking for attendance link. See, attendance link, we'll be posting it in between the session. Okay, so in the middle of the session, we'll be posting it in the chats section, and it will be like open only for like 2 or 3 minutes. Within that, we'll tell you. Okay, and within the 2 to 3 minutes, what you guys do is go fill up your attendance. Okay, screen is not appearing. Okay, Guru Hari, screen is not appearing. Can others see my screen? Can others are you able to see the screen? When your delay is about 2 minutes, and what can we do in 1 minute? Okay, better use whiteboard for teaching aptitude. While giving some display, read out the file. Okay, okay. So that is a good point. Celestine Jacob says there is a delay of 2 minutes, and then okay, okay, guys. So I'll talk to it about the person who is giving attendance. Okay, so we'll make sure that you have enough time to fill in the attendance. Okay, uh, just give me a minute. Okay, I'll fix the attendance thing, and then we'll start the session. Robin, அங்கே அவங்க என்ன சொல்றாங்கன்னா நம்ம நம்ம இது டிலே ஆகுது இல்லைங்க சார். நான் இங்கே ப்ராட்காஸ்ட் படி பேசுனதுக்கப்புறம் 2 மினிட்ஸ் டிலே ஆகுதுல்ல, அந்த அந்த டிலேலயே நீங்கள் க்ளோஸ் பண்ணிடுறீங்களாம்மா. ஸோ நம்ம சொல்லி அவங்க போய் சேர்றதுக்கு 2 மினிட்ஸ் ஆகும். அவங்க அப்படிதான் சொல்றாங்க 2 மினிட்ஸ் டிலே. ஏன்னா இல்ல நீங்க கொஞ்சம் எக்ஸ்ட்ரா டைம் தான் கொடுத்துருங்க அவங்களுக்கு. ரொம்ப ஏன்னா நம்ம டிஃபிகல்ட்டி நம்மளுக்கு தானே தெரியும். அவர் அங்க உட்காந்துட்டு ஒன்று சொல்லுவாரு. நீங்க வந்து கரெக்டா 2 minutes பேர் என்னங்க ஸ்டூடெண்ட்ஸ். சரி சரி. இப்ப நீங்க அது எப்ப நீங்க ஆன் பண்றீங்க? அஹ் நான் வந்து இப்ப அட்டெண்டர் ஷார்ட்லின்னு சொன்னதுக்கு நான் சரிங்க நீங்க சொல்லிருந்தீங்க. ஆ, ம். ஓ, 1 minute இப்ப போடுவாங்கன்னு சொன்னோமா? ஓகே சரி. Send another link, sir. Yes, Karthikeyan. Guys, can you hear me? Is everybody able to hear me? SNS guys. Yes. Screen is not visible. Vrinda Ganesan. But others say it is visible. So for how many of you screen is not visible? If screen is not visible, guys, I think the problem is on your side because most of them are able to see it, right? Guys, is the screen visible? Guys, respond. Is the screen visible? See, see for see. Yes, very good. Thank you, thank you. See, many of them are saying the screen is visible. Brinda. So you'll have to check your. I'll come back to attendance. Okay, I'll talk about attendance. A screen is visible to most of them. So Brinda Ganesan, check your side of the internet connection. Okay, if you, for most of them, screen is visible. Okay, now about this attendance thing, what is going to happen is, see, I'll come back to the background thing. Okay, background thing. I'll talk about the background thing. Okay, but attendance is. Uh, we'll be posting the attendance sheet in between the session. Okay, before the end of session we'll be posting it, but before we post it, I'll let you know. I'll tell you like within 1 minute the attendance link will be open. Okay, so I'll give you a warning, I'll give you a message, or I'll warn you that in 1 minute's time there will be an attendance link which will be posted. Okay, but once you receive that message, okay, whatever the delay that you have, once you receive that message it will be open for the next 2 to 3 minutes only. Okay, because there will be a problem if you don't give it. Okay, so whenever you have to give it as quick as possible. Okay, so make sure that your response is as quick as possible. So once I tell you that the attendance link will be posted within 1 minute. Okay, so there is a minutes gap between my voice and the utterance link being posted, right? So that will compensate for the delay, broadcast delay. Actually the broadcast delay is 15 seconds, it is not 2 minutes. Okay, somebody said it is 2 minutes. The broadcast delay is just 15 seconds. Okay, it may seem like 2 minutes because your internet's connection is slow or something like that, but to make it all work, guys, what we need to do is make sure that when I say that the attendance will be posted in 1 minute, you be ready. Okay, you be ready and be watchful for the attendance. I am talking about all the 102 students. Okay, right now there are 102 viewers here. So once I tell you that the attendance will be posted in the next 1 minute, be ready. Okay, it is like there's one of those Flipkart flash sales, right? So everybody are ready. uh, what about net? Think about Airtel user. The color contrast is present. Using the scribbling is a poor idea. Please note this in this which not everyone owns a super AMOLED screen with icon. Guys, I said I'll talk about the background issues. Surya Vikas. Okay, I'll talk about the background issues. Okay, and WhatsApp status is what about network problem? Think about Airtel user. Okay, okay. Uh, so here the thing is, so the attendance thing. So I was talking about the attendance thing, right? Now here, people, what you do is I'll give you the warning. Make sure that you give your attendance. Okay. Now about the background thing. Okay. See, this video was recorded. This video was recorded a long time back. Okay, so that is why we were not able to change it. So it is recorded, it is all done, it is sealed, so we cannot reopen it and change it, do additions. So the thing is, after that, okay, in the coming videos, you will see that I wouldn't have used a red marker. Okay, I wouldn't have used a red marker. It is an orange marker. Okay, so because I use an orange marker, it is clearly visible. Okay, I got the feedback that red is not visible. So don't worry. From the next sessions onwards, you'll be seeing an orange marker. Okay, so it will be visible. So don't worry about the background thing. Okay, maybe if not in the next video, uh, from the second next video we'll do that. Again, people still are giving. I think people are just logging in and then giving me this attendance messages. Okay, so I cannot keep repeating about attendance. Okay, you those don't message anything related to attendance. Okay, so I've talked about it. Um, Sufficiently. Okay. Now, guys, we have to get going. Um, what is the video did you all watch? Can you tell me which video you all watched? Which video you watched? So I want more interaction, guys. So more typing from you people. Okay, from 115 people, I want more interaction. Which video did you all watch today? Which video did you all watch? Yes, you have to be specific. Yes, number system. Okay, numbers. The types of numbers. Okay, so Sangeet says the types of numbers. Okay, so yes, number system, number system, number system. But you have to be more specific. Okay, what are the things that you learn? What comes to your mind when you say uh, when you what do you take away from today's video? I want you guys to type. What did you take away from today's video? What did you understand? Even a small thing that you understood, you can type. Okay, small things that you understood, you can type. Yes, types of numbers, number system, very good. Okay, but even small things that you took away from today's classes, you can type. What did you understand from today's classes? Okay, small things you can type. Rational numbers. Dinakar says he talks about rational numbers. Exactly. Okay, guys. Now I'm going to ask you a question. Okay, about rational numbers. Okay, let's see how many. What is the difference between prime number and odd number? Okay, Durai Raj. Okay, see, I'm going to ask you all a question, guys. Okay, let's see if you're able to answer this. Okay, let us see if you guys are able to answer this. Okay. Okay. Now, guys, Okay, which among these numbers, okay, 4 by 5, 5 by 3, 8, 5 by 24, I have given you four numbers. Which number among these four numbers is not a rational number? Okay, I want you to identify and the number which is not a rational number among these four numbers. Okay, now tell me, among these numbers, put it in the comment section. Okay, I want answers, guys. Which number among these four numbers is not a rational number? Okay, which number among this is not a rational number? Okay, guys, seems like attendance will be posted shortly. Okay, okay, so people saying 8, 5 by 3 is not a rational number. Okay, Brinda Ganeshan says 8, so looks like she's fixed her display problems. So good to see that. 5 by 3, 8, 5 by 24. Okay, Kripa Palani. Okay, Kripa Palani, I remember I remember you asking me a question. Okay, so I have an answer for it. Okay, so we'll talk about that also. That is also a very good question. So just wait till the end of the session. We'll discuss that. So most of you guys say it is 8, 5 by 24. Okay, so now what it says is any other answers, guys? Okay, any other answers? I've given you four numbers. Okay, so so okay. Now we'll see the now look at this. Now here, if I have to tell you rational numbers, a rational number is a number which can be expressed in P by Q format. Okay, rational number is a number which can be expressed in P by Q format where P and Q are integers. Okay, where P and Q are integers. Okay, so guys, what is an integer? Okay, both are integers. What is an integer? Okay, an integer ranges from it's like 0, 1, 2, and it goes on up to infinity. Okay, similarly on this side -1, -2, and it goes on up to infinity. Okay, so this is an integer. Okay, so 4 is it an integer? Yes. 5, is it an integer? So this is a rational number. 5, is it an integer? Yes. 3, is it an integer? Yes, this is a rational number. 8, is it an integer? This is nothing but 8 by 1, right? 8 is nothing but 8 by 1. So 8 is an integer, 1 is an integer, so this is a rational number. 5 is an integer, 24 is an integer, so this is also a rational number. So the okay, guys, link will be posted within 30 seconds. That is what it says. So, yes, plus minus infinity plus infinity. See, so all the four given numbers are rational numbers, guys. So nobody told me that. Yes, all the given numbers are rational. Yes, all are rational numbers. Shweta Shekaran, you're right. All are rational numbers. 8 can be written as 8 by 1. Yes, so it is this is understanding. Okay, so this is you have to watch the videos a little more carefully from the next time onwards. Okay, now then you could ask, okay, so the link is here. Okay, guys, so 3 minutes, so make sure that go ahead and give your attendance, everybody. Okay, guys. The message says the link has expired. Technical sessions of 6 days is good, but aptitude is not up to the mark. We need to improve, my humble opinion. ஹலோ சொல்லுங்க. நீங்க தான் அதில் மெசேஜ் அனுப்பிச்சிங்களா? சசிகுமார்னு வருது. டெக்னிக்கல் இந்த லைவ்ல மெசேஜ் அனுப்பிச்சிட்டு இருக்கீங்களா? இந்த லைவ் ஸ்ட்ரீம்ல இப்போ நான் பண்ணிட்டு இருக்கேன். லைவ் ஸ்ட்ரீம்ல SNS. சரி சரிங்க. ஓகே 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 சரிங்க. நான் பாருங்க. ஓகே நான் லைவ்ல இருக்கேன். அப்புறம் பேசுறேன். Okay, so guys, so we'll get started. Okay. Um, so here I'd like to talk about rational numbers a little bit. Okay. So I'd like to talk about rational numbers. I talked about I'm going to give you a number. Okay. So let's take 23.5. Okay. 23.5. Now I'm going to take another number. Okay. It is 46.666, and it goes on like this. Okay. Now another number. Okay. 49.78333, and this repeats, guys. This 3 repeats for infinity, and you have 54.89145678, okay, and so on like this. Now out of these four numbers, guys, I want you to know this is a rational number, okay, and this is a rational number, and this is a rational number, but this is not a rational number. Okay, I'm going to tell you the reason. Okay, the reason is very simple. uh, you guys, from the definition of rational number, what is rational number? Any number that could be expressed in p by q format. Yes, any number if you can express like this, it is rational, right? The thing is, first three numbers you can express in p by q format. Okay, but the last number you cannot express it. That is the reason why it is an irrational number. We call it an irrational number. Okay, so this is an irrational number because we cannot express it by p by q format. It is not at all possible. I'll tell you how to convert decimal to fraction, so that you'll know how, why it is not able to, this is not possible, this you cannot convert it into rational numbers. I'll give you the method. Okay, you'll understand why it is not possible. Okay, so listen to this carefully. Okay, it is important because you need to find if a given number is rational or irrational. Okay, now we'll take 23.5. Okay, 23.5. Okay, now 23.5, guys. take this to be A. Okay, take this to be A. Now multiply 10 on both sides. Okay, multiply 10 on both sides. What do you get? You get 10A, right? 10A will be equal to 235. See, our main objective in in converting a decimal to a fraction is, guys, is for you to remove this decimal point. Okay, that is your objective. If you are able to remove this decimal point, then you can easily convert decimal to fractions. Right here, multiply this by 10, multiply this by 10, what do you get? You get 10a by 10, 10a is equal to 235, which in turn will give you a is equal to 235 by 10. Yes, a is equal to 235 by 10. Now, is this in p by q format? Yes, this is in P by Q format, right? I told you where P and Q are integers. Yes, so P235 is an integer, 10 is an integer. So this is why I tell this is a rational number. 23.5 is a rational number because you are able to convert it in P by Q format. Okay. Now I gave you a second number. Remember, I gave you a second number which was something like this: 46.666, so on. Okay, guys, this vinculum, we call this vinculum, this dash we call it as vinculum. What it means is this 666 repeats infinitely. Okay, this 666 repeats infinitely. That is what this dash emphasizes. This dash tells you that this digit 6 which comes after the decimal point will repeat infinitely. That is what this dash or vinculum. Okay, it is called vinculum. So this vinculum, that is what it represents. Okay, that the digit repeats infinitely. So now how do you convert this to p by q format? Okay, now again I told you, you have to remove this decimal point. How do you remove this decimal point? There is one easy way of doing it. See, take this to be A. Okay, this is A. Okay, this value is A. Okay, now what you do is multiply both the sides by again 10. Okay, if I multiply by 10, what do I get? 10A is equal to, what will happen to this? This will become 466.666. This will go on forever, right? Yes, 466.66. So A is 46.66. 10A will be equal to 466.66. Now what you do is subtract this from this. Okay, so if you subtract this from this, what will happen? 10A minus A is 9A, right guys? 10A minus A will give you 9A. Subtract both left hand side and right hand side. So 9A will be equal to, now if you subtract 466.6666 to 46.6666, this part after the decimal, okay, this part after the decimal, what will happen? Will be totally gone, right? Because 0.6666 minus 0.6666 is nothing, right? Zero, right? So this total decimal part is gone. Right now you are left with only 466 and 46. What is 466 minus 46? It is 420. Yes, 466 minus 46 is 420. So A is equal to 420 by 9. Okay. Now again, have you converted into P by Q format? Yes. Now this is again P by Q format. So this number that you see, 46.666, is also a rational number. Okay. So I am going to give you one more number, guys. So watch this carefully. Okay. Now A is equal to 123.45373737 dot 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 dot. Okay, now how do we convert this number? Okay, now again our point is to somehow eliminate the decimal point. Okay, now what I'll do here is I'll multiply this by 100. Okay, I'll multiply this by 100. Now if you multiply this by 100, this will become 100a, and this will become 1 2 3 4 5.3737, and this goes on, right? And this goes on like this. Okay, now 1 2 3 4 5.373737, it goes on like this. So now what you do is again multiply this by 100. Okay, again multiply this by 100. Okay, I am trying to see are you understanding what I am trying to do here? I am trying to move this point from here to here. Okay, then again from here to here. Okay, so multiply this by another 100, you will get the 10,000 like this. You will get 10,000 A is equal to 1 2 3 4 5 3 7. Okay, point, again we have 3737. This 37 goes on forever, right? Now guys, our objective is to make the digits after the decimal. Okay, so look at the digits after the decimal, look at the digits after the decimal, they must be same. We must make it same. So by doing this and this, what did I do? By doing this and this, what have I done? I've made the digits after the decimal to be same. Why should they be the same? That is when you subtract, they'll get cancelled. Okay, so this minus this will be 0. So the whole decimal part will go. Okay, we have to remove the decimal part, I told you, right? So to remove the decimal part, what you have to do is you have to make sure the numbers after the decimal point are same. So here 3737, 3737. So I'm making it the same so that when I subtract, what is 10,000 minus 100? It is 9,900, right? So 9,900, when you subtract, you'll get 9,900A, which is equal to, now when you subtract, this whole part and this whole part will be gone. Okay, now you just have to subtract 1 2 3 4 5 3 7 minus 1 2 3 4 5. Okay, so that will give you the final answer. Okay, so let me tell you what is the 1 2 3 4 1 2 3 4 5 3 7 minus 1 2 3 4 5. You are getting 12, a number which is 1 2 2 2 192. Okay, so now again A is written in P by Q format, right? Yes. So guys, we've seen 3 examples where A is written in P by Q format. So these 3 examples are the examples of rational numbers. Okay, the first example was 23.5. Okay, it was a number. Okay, we look at those again. Okay, I'll just write it down so that you know. So first example was 23.5. Okay, so 1 minute. Okay, I'll just show it here. So look at this example, guys. So look at these examples. So look at these examples, guys. See, 49.7777, this continues, right? So we saw how to convert this to P by Q. Okay, similarly 56.828282, you know how to convert this to P by Q. Again 89.57, then 857, 857, 857, 857. This was the last example, okay, where I multiplied this number by 100 and then again I multiplied it by 10,000, okay, to get the answer. Okay, now see, these are what we call as, okay, rational numbers, because they are recurring. But look at this, okay, 365, okay, look at this, 89365, yes, 865, then 865. So you, from here it says it is repeating, yes, 865, 865, yes, can you see it, 865, 865, 865. So all these are recurring numbers, okay, although they are infinite, they are recurring numbers. But look at irrational numbers, okay, I'll give you an example of irrational number. Okay, an irrational number is 65.25. Now this is a irrational number, guys. See, if there is an end, okay, suppose if this is the number, you cannot call this irrational because there is an end. Wherever there is an end, you can convert it into p by q. Yes, whatever the number of digits you have, that many zeros you multiply here, okay, that many zeros you multiply, what will happen? This will become a rational number, right? So whenever there is a number which has an end, it is surely a rational number. But when there is a number which doesn't have an end, okay, which is recurring, sorry, which doesn't have an end, okay, it doesn't end. Now those numbers can be rational and can be irrational. Okay, when is it rational and when is it irrational? Okay, it is rational when there is recurring of digits. Okay, when there is recurring of digits. So look at this example, 7 is repeating, yes, 7 7 7 7. So this is rational. Here 8 2 is repeating again and again, yes, so it is rational. Here 857, okay, 857 is repeating, 857 857 857 857. So this is rational. Okay, here if you see again, 865 is repeating, okay, 865 865 865 865. But here there is no number which is digit which is repeating. Okay, if you look at this carefully, there is no digit which is repeating. Okay, and to add to that, it is non-ending also. So non-ending, non-repeating decimal numbers are irrational numbers. Okay, so note this point. Okay, non-ending, non-repeating decimal numbers are irrational numbers. That is why people say square root of 2, okay, square root of 2, okay, then pi, you know pi, right, 3.14 something you will get, right? So there, if you see, look at these values, the value of pi, the digits won't repeat, okay, and it is a non-ending number. So that is why we call pi, square root of 2 and all as irrational numbers. Mostly square root of square roots and constants, pi, e, those are the irrational numbers. Okay, yes, guys, so did you understand irrational numbers? You have questions, any questions, any doubts regarding that? Did you get it? Yes, guys, did you get it? Yes, so people say they're clear. Okay, very good. Okay, now Preet Prabhu, Dhanalakshmi, Satapan, they all say good. Okay, understood. Okay, so use this and try to solve problems. Now what we'll do is I'll talk about another comparing fractions. Okay, I want you to understand how to compare fractions, guys. Okay, yes, okay. So everybody says they got it. you have to know how to compare fractions. Okay, it is important. So we're going to see something that is this is the question. Okay, so what they've given you is you have to arrange 2 by 15, 18 by 29, 7 by 18 and 10 by 87 in ascending order. Okay, so I'm going to tell you a few methods which you can use to compare fractions so that it will help you. Okay, now 2 by 15, 18 by 29, 7 by 18, 10 by 87. Okay, so these are the your numbers. So before you understand that, uh, just listen to this. Okay, now yes, 2 by 15, 18 by 29. Okay, and we have 47 by 15, right? Okay, 10 by 87. 7 by 18. Okay, it is 7 by 18. So it is 7 by 18. Okay, so now the way you which compare fractions, guys, before you understand how to compare fraction, I'm going to give you a couple of methods. But before you do that, what I'd like to tell you is just tell me just 2, 3, 4. Okay, 2, 3, 4. Now in what order is this these three numbers arranged? Just put your answers in the comment section. 2, 3, 4. In what order are they arranged? Is it ascending order or descending order? Okay, is it ascending or descending? Okay, put it in. Put, put your answers, guys. I want the answers. 2, 3, 4. Is it in ascending order or descending order? Okay. So I want to see square root number is rational or not. It is Kripa Palani. It is rational. Root of 7. Okay. Because guys, see any Kripa Palani asks is root 7 a rational number? It is irrational number. Okay. The reason is, see, what is root 4? What is root 4, Kripa? Root 4 is 2, right? What is root 16? Root 16 is 4. Okay. So, root of, yes, ascending. Yes, very good. Yes, ascending. Okay, they are in ascending order. Very good. See, root of a perfect number is always, or root of a perfect square, I should say. Okay, is always a integer, right? Because root 4 will give you 2, which is an integer. Root this thing will give you, so we'll, okay, anyway, we'll just talk about it. I'll come back to Kripa's question. Okay, so Kripa asked, uh, or we'll explain Kripa's question first and then move on to this. Okay, so Kripa says, see, root 4, root 16, okay, root 36, root 49. Now all this are not irrational numbers. These are not irrational numbers because this is 2, this is 4, right, guys? This is 6, this is 7, right? So these are all not irrational numbers. But root 7, if you take, you will get something like, so if I have to be more specific, it will be like 2.8934. The value will be something like this, root 7. Okay, So like I told you, because it is non-ending and no digit is repeating or recurring, this is an irrational number. So all roots except perfect squares. Okay, when this number is not a perfect square, okay, this number should not be a perfect square. Okay, not a perfect square. If this number is not a perfect square, guys, then 7 is not a perfect square, right? Then it is irrational. Okay, this is an irrational number. Okay, but if it is a perfect square like this, okay, in this case these are all perfect squares, then these numbers are rational. 2, 4, 6, 7, all these are rational, right? Because 2 is nothing but 2 by 1. Okay, 4 is nothing but 4 by 1. 6 is nothing but 6 by 1. 7 is nothing but 7 by 1, right? So these are all rational numbers. Numbers which are not perfect squares, if you take roots of numbers which are not perfect squares, it will be irrational only. So root 2 is irrational. Okay, root 5 is irrational. Okay, all these are irrational numbers. Okay, so we'll just look at this thing. Okay, now so I was asking you guys what happened to 2, 3, 4. Okay, I was asking you guys what 2, 3, 4, what order is 2, 3, 4? You all said it is ascending order, right? Now what I want you guys to do is to take the reciprocal. You all know what reciprocal is, right? So reciprocal of 2 is 1 by 2. Reciprocal of 3 is 1 by 3. Reciprocal of 4 is 1 by 4, right? Yes. So now see, you said this is ascending order. Yes, I agree with you. This is ascending order. Okay. Ascending means from small to large. Okay. 2 is small, 4 is large. Now what is this order? Okay. This order, which is 1 by 2 is large or 1 by 3 is large, which is larger. Okay. You can see 1 by 2 is larger than 1 by 3. Okay. 1 by 3 is larger than 1 by 4. So this is what descending order, right guys? Yes. So this is what you have to keep in mind when numbers in ascending order are made inverse or taken reciprocal of, ascending order becomes descending order. Okay, so this property we are going to apply in this to get our answer. Okay, because if you go the conventional way, then it is going to be a big procedure. Okay, if you go in the conventional problem, what will happen is it will be a big procedure. So here what we are going to do is, guys, we are going to apply this and do it. Okay, take the reciprocal, because finding 2 by 15 is difficult, right? Is it possible for you to find 2 by 15? You can find 2 by 15, but it will take a lot of time. Okay, so what we do is, instead of finding 2 by 15, we find 15 by 2. Yes, 15 by 2 is possible, right? 15 by 2 is easy for you to find. What is 15 by 2? 7.5. Okay, so that is why we take the reciprocal and find the value. What is 29 by 18? Yes, 18 by 90, 18 by 29, we have, if you do reciprocal, you will get 29 by 18. If you do reciprocal of 7 by 18, what will you get? 18 by, you will get 18 by 7. Okay. If you do reciprocal of 10 by 87, you will get 87 by 10. Okay, so you do the reciprocal of this, guys. When you are finding the value 29 by 18, you need not be very accurate. Okay, you don't need to find the accurate value of what 29 by 18 is. Okay, you just have to find an approximate value. See, 29 by 18 is approximately what? 1.5. Yes, how do I say it is 1.5? Because from 18 to 29, it is a difference of 11. Okay, 11 is how much of 18? Approximately half of 18, right? Yes, so you just say it is 1.5. Now again, 18 divided by 7, approximately 7 2 times is 14. Okay, 7 2 times is 14. You have extra 4. 4 is how much of 7? again 4 is like approximately half of 7. Okay, so you can say it is 2.6. Okay, 2.5 will be to exactly 17.5. Okay, but 2.6 something like that. So this is 8.7. Okay, now guys, if you have a look, okay, 7.5, 1.5, 2.6, 8.7. Now you can arrange it in ascending order, right? If you do it in ascending order, see, if you are you what you've done is the given fraction is reciprocal. Okay, you want ascending order. Okay, now it is in reciprocal, so if you arrange this in descending order and then reciprocal it, what will you get? You will get ascending order, right? Yes, from you arrange this in descending order and then do the reciprocal. Okay, so if you arrange this in descending order, what will happen? 8.7 will come first, 7.5 will come next. Okay, then 2.6 will be the next and 1.5 will be the next. So what I have done is I am arranging it in descending order. Why am I arranging it in descending order, guys? I am arranging it in descending order. The reason is only if I arrange it in descending order, if I take reciprocal, we've already reciprocaled it. Okay, and so you have to reciprocal it one more time. So when you do the reciprocal, it will become ascending order. Okay, so 8.7 is nothing but 87 by 10. Yes, so guys, you if you reciprocate, what will happen? 10 by 87. Okay, 7.5 is 15 by 2. You reciprocate, what will you get? 2 by 15. Okay, now 2.6 is 18 by 7. If you reciprocate, you will get, yeah, 2.6 is yes, you reciprocate, you will get the 7 by 18. Okay, now 1.5 is 29 by 18. Okay, you reciprocate, you will get 18 by 29. Okay, guys, so as you can see, this is the order in which this is the ascending order. You get the final answer. Okay, just by understanding this concept, you are making things easy. Okay, so did you all get it? Did you understand it? Just put your comments. We'll see if you got it or not. Yes, did you get it? Okay, so Sangeet says he got it. Guys, others? Okay, Kripa, yes sir, understood. Okay, guys, very good. Okay, now I'm going to teach you one more method and then we'll wind the session. Okay, the one more method, guys, uh, see, every time you need not use this. Okay, but in places where it is applicable, you can use it. Okay, uh, now there is a question, guys. See, look at this. There is a question which says 22 by 7, 138 by 43. Which one is greater? Okay, this is what you have to find. 22 by 7, 138 by 43. Which one is greater? Okay, now we'll see how to do this. Okay, uh, so so 22 by 7, 138 by 43. Guys, to find which is greater, I'm going to tell you to compare fractions, to compare this and see which one is greater. I'm going to tell you a method. Okay. Now, what you do is take this 43 and multiply this with this 22. Okay. Take this 7 and multiply it with this 138. Okay. Now, if you multiply 22 and 43, the answer that you get is, you multiply 22 and 43, the answer that you get is 946. Okay. So, you take this 43 and then multiply it with 22 and write the answer here itself. Okay, like this, 946. Now what is 138 into 7? If you do 138 into 7, you will get 966. Okay, so which side is greater, right side or left side? Right side is greater, right? So this fraction is the greater fraction. Okay, compared to this is the greater fraction. See how simple it is. See, this you can apply for the previous problem also. Okay, so whichever method you find it to be easy, okay, you apply that. Okay, any two fractions you can easily find like this. Okay, so we are going to, I'll give you one more example where you can see for yourselves. Guys, you all know 1 by 2 is greater than 1 by 4, right? Now we let us apply and see. Okay, now what happens? You cross multiply this and you cross multiply this. What will happen? This will become 4. This will become 2. Correct? Yes. Is 4 is greater than 2. So 1 by 2 is greater than 1 by 4. Okay. So this fraction is greater than this. Okay. So two fractions you can compare very easily. Okay, using this method. Just cross multiply. Whichever side is the greater number is the fraction that is greater. Okay. So I'll give you one more example so that you understand even better. 3 by 8. Guys, you know 3 by 8. You know 5 by 8. Okay. See, when the denominators are equal, you clearly know that the whichever the fraction which has the highest numerator is your greater fraction. Correct? When the denominators are equal, the fraction which has the highest numerator is your higher larger fraction, right? Here the now let us cross verify that. Okay, what do you do? This into this into this, what will happen? 8 into 3 is 24. Okay, 8 into 5 is 40. Which one is greater? Which one is greater, guys? This is greater, so therefore this fraction is greater. So you can see that this method works. Okay, so you can apply this to methods. Okay, so did you understand this? Just give me a thumbs up, say yes if you understood this. Okay, so you got it right. Okay, so this, that's about it, guys. But I just want to finish this off with Kripa Palani's doubt. Okay, see, Kripa Palani, she had asked in the last session that we had. I'll just show you the screen. Okay, so this is what she asked. Okay, um, so I promised her I'll give her an explanation, and here is the explanation. So this is a question. Okay, Kripa Palani asks, a positive number is divided by 100 to get a remainder thrice as the quotient. If the number is divisible by 11, then how many such numbers are possible that are less than 10 lakhs? I get, no, sorry, it is 1 lakh. Okay, how many such numbers are possible? Just go read this question carefully. Try to understand this question. I'll repeat it again. Okay, so it says, a positive number is divided by 100. Okay, there is a number, we don't know what that number is, but if you divide that number by 100, okay, you get a remainder thrice as the quotient. Okay, the remainder is thrice the quotient, which means if the quotient was 1, the remainder should be 3. The quotient was 2, the remainder should be 6, right? So if the number is divisible by 11, Okay, what number? The number which you are dividing. Okay, the number which you are dividing is divisible by 11. Then how many such possibilities are there? Okay, how many such possibilities are there? Okay, so this is the question, guys. Okay, there is a number, you are dividing it by 100. When you divide it by 100, if you get the quotient as 1, the remainder must be 3. If you get the quotient as 2, the remainder must be 6. If you get the quotient as 3, the remainder must be 9, right? So, and to add to that, the number must be divisible by 11. Okay, the number which you are dividing must be divisible by 11. How many such numbers are there? Up until 1 lakh. That is what they are asking. Okay. Now, I am going to tell you, give you the explanation for this. Okay, I'll do it here itself. Okay, guys, this is like checking your understanding of this thing. Okay, now let us take this number. Okay, let us take this number, guys. 103. Take this number 103. Okay, now you divide 103 by 100. Yes, you divide 103 by 100. What is the quotient that you get? It is 1, right? Because 1 times is 100. Okay. What is the remainder that you get? The remainder that you get is 3. Now, this is what they are talking about when they say that the remainder is 3 times the quotient. Okay. Here, you can see the remainder is 3 times the quotient. Okay. But here, this 103 is not divisible by 11, right? So, this is not divisible by 11. So, we cannot take 103. Okay. Why we cannot take 103 is 103 is not divisible by 11. Okay. So, it is impossible to divide it by 11. Okay. Now, so you have to take numbers so which are divisible by 11. Okay. Now, you can put it like this, guys. The number, this is dividend, this is quotient, this is remainder. Yes, this is divisor. Okay, but I should also say this number is dividend. Okay, now what did I tell you? This number must be divisible by 11. Yes, so if you take this number to be k, this number is nothing but 11k. Correct, guys? If you take this number to be k, this number must be 11k, right? Because this should be a multiple of 11. Okay, only when it is a multiple of 11, this number will be divisible by 11. Okay, so this is what we are looking for. We are looking for 11k, which will give you a quotient which will be 1 and a remainder which will be 3. Okay, so what we do, guys, is 1003. Okay, 1003. Now you tell me, you divide this by 100, what will you get? Or I should say it should be 1030. Sorry, 1030. Okay, divide this by 100, you will get 1 times is 100, you will get 30. Okay, 1 minute, okay, just a minute. Okay, okay. Uh, Okay. So, guys, uh, this is sorry, I just got stuck here. 10,300, guys. Just take this number 10,300. Okay, 10,300. Okay. Now, if you take 10,300, okay, okay, guys, what I'll do is, so we'll come back to this question later. Okay. Uh, okay, there seems to be a little problem there. Okay, I think we'll wind up the session, guys. So, Kripa Palani. Okay, so I'll make sure that I answer this question. Okay, um, we'll come back to this later. Okay, so I think we're running out of time, so that is the reason I cannot continue. Okay, so we'll continue with this in our next tomorrow. We have a session. Okay, so tomorrow I'll give you the correct explanation for it. Okay, okay. Uh, so I hope you got something out of today's class. Types of narration. I know. I hope you were able to identify rational numbers. If you see a number, you must be able to know if it is rational or not. Okay, and irrational numbers. And you also knew. You also found new ways to compare. Yes. Okay. So Kripa Palni says okay, fine. Okay. So you also found ways to compare fractions. You should know how to be able to compare fractions. Okay. Okay, guys. So that's it. So we'll see you tomorrow. Okay.